So now that we've talked about the process of making concentrations, oh, wait, I'm still good, never mind. So now that we've talked a little bit about concentration, how to calculate it, we probably know that concentrations are not set in stone. So there are ways that we can change the concentration. And I just like the little, I know, I was like, and I would have just laughed if I kept going. All right, so now that we've talked a little bit about concentration, what it means, how to calculate it, we can now find out how to change it. Because as you can imagine, concentrations aren't set in stone. So how do we actually change the concentration? Well, I can do one of a few things. So let's first just talk about concentration this way. So let's say I have a solution. There's currently 1 liter of solution in there. And in that 1 liter, I've got these 5 red dots, and let's just say each red dot represents a mole. So red dot equals mole of some kind of substance. Well, right now this would be 5 moles per liter, and it has a concentration of 5. The molarity is 5. So how can I change it? Well, there are 2 components, right? There is a solute that is dissolved in the solution, and there is a solvent. So I can take that solvent, let's actually bring it down here, and I can increase or decrease my solvent. If I did that, what would happen? Well, now, let's say I double my solvent. Now I have 2 liters. My solute is still the same. So my new molarity would be 2.5. 5 divided by 2 gives us a concentration of 2.5 moles per liter. So what's the other way? Well, I can increase or decrease my solute. So what happens if I increase it? That'll do. Well, because I'm talking about my original drawing, I still have 1 liter. But now let's say I double it. I double the amount of moles. Now I would just be 10 liters. So increasing solvent would decrease my concentration, and increasing the solute would directly increase my concentration. So now what we want to do is just say, what is this process really doing? Well, this is the process of dilution when we talk about the solvent. So dilution, the changing of concentration by increasing the amount of solvent relative to the solute. And so that's going to be pretty important. So the overall formula for this process of dilution, or let's say changing the concentration, has a mathematical formula that would be M1 V1, the concentration times the original volume, is going to equal the product of M2 and V2. So if I increase my number of moles, well, that's probably going to show up in my final answer as still the same number of moles, but this is concentration. So for concentration, that's going to change as we change the volume. Just a basic bad explanation about the relationship between molarity and volume. I was really just trying to cover myself because I forgot that was molarity. So now let's actually look at a problem that involves dilution. So 50 grams of NaCl were dissolved in water to create a 0.4 molar solution. Adding an additional 2 liters of water would dilute the NaCl solution to what concentration? All right, well, we know we have 50 grams of NaCl. So 50 grams. Shout out to them making it difficult by not giving us the mass, 22.99 and then 35.453. So each 22.99 plus 35.453 would be 58.443. And that is the molecular weight of NaCl. So 50 divided by that number would give us the number of moles. And the number of moles is equal to 8 or 0.8555. I'm just going to say 0.86. And of course, that is the number of moles of NaCl. Now, they were dissolved into water to create a 0.4 molar solution. That is molarity. Great. So, let's just say we originally had 0.86 over some kind of solution or some kind of water solvent. And that equaled 0.4. Why am I doing this calculation? Because I don't actually know the volume yet, so I can't do m1v1 equals m2v2. So something just hit my eye. I'm going to push through. So 0.4 times L is equal to 0.86. So dividing both sides by 0.4. How do I change that setting so I don't keep switching to eraser? Divided by 0.4 is equal to 2.15. So for liters, I know I have a 2.15 liter solution. So now I know M1 and V1. So M1 V1 equals M2 V2. We have a value of 0.4 for the molarity. The volume is 2.15, and that is going to equal some value of M2. And what's our V2? Well, V2 is just going to be that 2.15. Let's bring this out. And as it says, we added an additional 2 liters. So this was a dilution. We increased the solvent. So 2.15 plus 2. Did I take everything? Yes, I did. What just happened? Whatever. All right. Hopefully that comes back. This will just be 4.15. And over here, we have 0.86 equal to M2. That's 4.15. Let's make sure I did that right. 0.86. So 0.86 now divided by 4.15 is equal to 0.207 or 0.21, which is our concentration of the final NaCl solution after we added 2 liters of water to dilute it. So that is an example of a concentration problem and a dilution problem. Very popular stuff.